a definition of what is lean management. Okay, this definition comes from Shah and Ward. If you want to look for the paper, it was written in 2003. The paper is called, you can Google it, Lean Manufacturing Context Practice Bundles and Performance. I can recommend that you read the paper. It is very good, and this definition that these people give, Sean Ward, of lean management is as follows. Is understood as a socio-technical management system that aims to reduce value stream or process variability. Okay, there are many concepts here. The first one is a socio-technical. We will look at each one of them, okay? First one is a socio-technical. The second one is we look at the management system. We looked at it, what a management system is the other day. The third one is that aims to reduce process value stream variability. And these three concepts are important. Okay. So let's look at the concept of socio-technical. What is meant by a socio-technical system? Imagine you have two axes, one horizontal in which you increase social complexity, and one vertical in which you increase technical complexity. Okay. On the social level, we find we can find the individual level. This is each one of you, okay? So this is the individual level. And at this level, what we're looking for is for trustworthiness. being trustworthy, which means translated that you have a balance between your character and your competence. This is important. You don't call a doctor to treat you that has a very good character but has a competence 20 years old because you don't think this doctor is trustworthy. You also don't call a doctor that has a very good competence but is going to prescribe you some operation that you don't need. Okay? You need both. You need both character and competence in order to be trustworthy. And this is true for any level of for any role you play in life. Okay? The next level, once you have achieved trustworthiness, the next level is the relationship at an individual level. The next level is the relationship. The relational level. You have two people. Complexity increases. Okay? This is the relational level. And here we're looking for trust. So without trust, we cannot achieve trust. Without trustworthiness, we cannot achieve trust. That's why the individual level is the basis for the relational level. Without trustworthiness, you cannot achieve trust. The next level is once you get to a managerial role. So this is your worker, your people, your process owner, and this is the hand of the management. You get to the managerial role. Managerial role, and here you're looking for empowerment. Here you look for empowerment. You cannot empower people if you're not having trust with them. You cannot have trust if you're not trustworthy. This means in order to be a good leader, you need to have both the character and the competence. Both. Otherwise, you cannot be a good leader because you cannot empower your people because you don't have trust with them. The last level is the organizational level. Let's say all these managers are trying to empower their people, controlling logistics, production, and so on and so forth, and they're trying to achieve a certain set of strategic goals. Okay, and this is the organizational level. And at an organizational level, what you're trying to achieve is alignment. Okay, a common direction. I repeat the whole thing in German. So, auf einer individuellen Ebene suchen wir Vertrauenswürdigkeit. Die Vertrauenswürdigkeit besteht darin, dass Menschen ein Gleichgewicht zwischen Charakter und Kompetenz haben. Wenn wir das haben, dann können wir auf der Beziehungsebene Vertrauen aufbauen. Wenn wir nicht vertrauenswürdig sind, dann können wir kein Vertrauen aufbauen. Wenn wir Vertrauen aufgebaut haben in unserer Mannschaft, dann können wir diese Menschen befähigen als Management. Und wenn wir genug Menschen befähigt haben, dann können wir in der Organisation eine gemeinsame Ausrichtung anstreben, nämlich Alignment. Okay? Und natürlich von links nach rechts steigt die soziale Komplexität. Ist verständlich? Any questions, please? Am I going too fast? So, a little bit of feedback would be nice. Everything cool? Yeah. Good. Then I shall continue with the next level. The technical level is easier, I guess, to visualize because it's just different complexity levels. Let me put an example from, let's say, the factory. Okay, just at a very low shop floor level, you have a machine. Okay, so this is the shop floor level. Okay. If you have many of these machines together, then you have a production line. Okay, and just by putting many of them together. If you have many of these lines together, what you get is a factory where you have your different processes put in a streamline, so you get a factory. And if you put, let's say, many factories together, what you get is a supply chain. Let's say we put here, this is the world, and then we put here several factories around the globe, one factory, other factory, other factory, and they have different suppliers. Then you get so-called supply chain. Maybe you have heard of these concepts before. Okay, so when you grow up in this direction, you increase your technical complexity. And the thing is that what we're trying to do with lean management is to reduce the process variability in this socio-technical context. Okay? So it's a very complex issue because you have people on all levels, you have processes on all levels, and of course this is just a model, okay? This is just not the full reality, but what we have is a socio-technical landscape in which what we are trying to do is to achieve goals while increasing trust. Okay, so this is a management system per definition. We saw that the other day, I guess. Don't remember. Wait, let's see. Professor Vorlesungen. Project management on the first day. Yeah, so we saw what a management system is on the first lecture. And so the second point is done. So what we do with the third point, now I'm going to try to explain what we do here with the reduce of the process variability. So is it clear what we do, what the socio-technical means, socio-technical dimension means? So this could be very easily a question in the exam. So explain, please, the socio-technical dimension of cyber-physical systems, and you need to explain me these two arrows and paint the graphic and so on. Okay, so the the third point, or the systematic reduction of variability, what this means is simply so the reduce process variability. What this does is that we take, or what this means is that we take a process, okay, let's say this is time, and we measure a certain, let's say, KPI, key performance indicator of this process. Let's say we measure the quality, okay, of a certain machine, and we have, on each point in time, we have measurements. And let's say we measure every minute the quality, and then we get a mean value. Okay, the mean value. Oh, sorry. This is the mean. And we also get a standard deviation. Let me put it here, mean, and then we get a standard deviation of the process. Up and down. We get a standard deviation of the process, meaning this process is normally distributed. And then we have a sigma. We know from statistics that mean is the first momentum divided by the number of samples, and that sigma squared, the variability, the variance, is the second momentum from the mean divided by n minus 1. Okay, this we should know, or you should know from previous lectures in the past. Okay, this is just basics statistics, and what we're trying to do is we're trying to get from sigma 1 to sigma 2. Okay, so basically lean management is just trying to get your let's say get your business from one level of sigma to the next level of sigma. Let's say to reduce the variability. Let me paint it green. We are trying to get all the points after doing lean management around the new levels of sigma. So in other words, we're trying to get a more controlled process. Okay. With lean management, we try to systematically reduce value stream variability. Okay, so sigma 2 should be smaller than sigma 1. This means we strive for process control. Okay. The word management, I recall, okay, management or management system means achieving goals while increasing trust. Okay, achieving goals while increasing trust. So there is a human dimension here. I cannot achieve trust if I'm not trustworthy, and so on. And I cannot achieve my goals if I don't empower my people, and so on and so forth. So here you have the goals, here you have the trust, and you need empowerment, you need trustworthiness. Okay, so this is implicit in the definitions of the system. Is it clear? Questions? If you are not very confident with statistics, just get back to your previous lectures, to your previous statistic notebooks, because we're going to need the math, okay? So this is just for one KPI, okay? One KPI, but usually, typically we have several KPIs. So the method that we will learn later on is going to be called for several or for many KPIs, let's say. This is just for one KPI, so that you have it in your mind. This is for one KPI. For many KPIs, just as in usual management systems, we will use the so-called principal component analysis. If you want, you can Google it. Just to get familiar with it, we will look into the math of it later on. Okay, principal component analysis. This is basically, I'm going to do it for just two dimensions so that I can paint it, but you can do it for any number of dimensions. Let's say you have two KPIs, let's say the width and the height of a measure of a product, whatever, and you want to find, so you measure here the process, okay, different parts, and here it is very obvious that X and Y are not the best ways to describe this data set. The best way to describe the data set is this direction, okay, something like this. because it's the direction that has less distance to all the points. So this is going to be our principal component number 1. Okay, this is just intuitive. Okay, and then the second direction, the principal component number 2, is going to be perpendicular to it, to the first one. So this is going to be our principal component number 2. PC2. Okay, and these two KPIs are going to be describing our data set best. So the variability is going to be best explained by these two KPIs, by these two principal components, better than with the other X and Y original directions. Okay, so the two PCs, principal components, explain a certain percentage of the dataset variability and are perpendicular to each other, which means that they are independent from an algebraic perspective, and this is important later on for the management system description. Okay, so we will learn how to calculate the principal components with certain examples later on. Okay. For now, it is important just that you understand that we are trying to systematically reduce the process variability, and this is done by certain statistical methods. Any questions, please? Any questions? So we saw the other day that our cyber-physical networks can be described as networks. We have learned how to measure networks with average path length and stuff, okay? But there are many organizational structures that can be described as networks. And depending on their structure, they can get better or worse performance. So let's put some examples to it. Let's say the x-axis is the size of the network, n, number of nodes, just as we had it before. And here we get our average path length, APL. Okay. It turns out that if we have a one-dimensional 1D network, let's say we have a pure hierarchical network, like in the military, okay? Pure hierarchy. Example is the military. where you have your chain of command, let's say. Okay. The average path length is proportional to n to the potence of 1 divided by 1. This means that the more n grows, the more APL is going to grow. Okay. Basically, what this means is that the higher or the bigger your network, the longer it's going to take to get information from A to B. So it's very, very, very ineffective. Okay. That's why organizations turn to intuitively they tend to create new organizational structures like a matrix organization. Probably you've heard of it before. And the reason why a matrix organization works better than the pure hierarchical organization is just based on the structure of the network that is created. Okay, so usually you look at the horizontal level, which is the process level, and the vertical level, which is the hierarchy level. And here what you get is an APL which is proportional to n to the potent of 1 divided by 2. Okay, so 2, here you had the 1, so, and this means that with increasing size of the network, you get better performance. You get the information to be translated to the next level on a faster way. So this means that if you have the same level of the same number of nodes for any given system, okay, the matrix organization is going to be working better than the pure hierarchical organization, because the average path length is going to be lower. Okay? So here you have your matrix, your people working there. This makes sense? You can translate information faster in the matrix here from A to B than here from A to B. Okay? Are you cool with that? Have you heard before about the matrix organization? Yes, so probably yes. So now you know why, okay? Why this is better. I don't think you've heard about this before, about why matrix is better. Just some qualitative theory, but this is the reason why it works better from a quantitative perspective, from a network perspective. So, but you can also go 3D, okay? And this is where companies are struggling right now. You can get let's say a factory in Taiwan to have a matrix organization, and another factory in Germany to have a matrix organization, and then just transfer information from one factory to the other. And this is what Japanese call Yoko Tenkai. Okay, this is the standardization procedure. Let's say you want to get one production line from one factory in Germany to the next factory in, let's say, Turkey. Here your APL is n to the potence of 3. Okay, and you see the game is always the same. Here you go a little bit down again, n to the potence of 3. So you're always gaining some performance with the same people, same number of people, same number of resources. You're gaining performance. So you're doing better, but it's more difficult to implement. So if you get 4D, then this is where Google is struggling right now to get projects on a 4D organization. So you get all these cubes of 3D matrix, and then you get all these cubes to work together, to perform together in a 4D organization, virtual organizations, okay? So here the APL is n to the potence of 4 and stuff like that, okay? So it just gets ad infinitum. This is where most companies are right now struggling to get to a virtual digitalization world. What is the limit, okay? What is the, so you can go and keep on adding dimensions and stuff, but the limit is set by physics, okay? As long as information transmission, it costs energy, so you get the limit to the small world organization, where your average path length is logarithmus of n. And this is where best companies are working today. So for instance, Toyota, and you can get also the theoretical limit is where the human brain is working. The human brain has an average path length of logarithmus of n, and so you're talking about scale-free networks. Okay, scale-free or small world. But real-world organizations are working between n and n to the potence of 4. Okay. So this is a very interesting, in my opinion, issue. You can go and look for in my list of publications. You can go and look for the lean brain theory. There is a book in the bibliothèque you can get. The lean brain theory, and you can read more about this. Okay, super interesting if you like strategic organizational design. Anyway, I'm going to give you an exercise. It's a homework. Okay, please. Oh, before I give you the exercise, is it understood, understandable? Does it make sense? If you increase the complexity with the same elements, if you increase complexity, you get better results. Like, let's say you get 10 computers, you put them in the line, okay? You put it in one line, 10 computers, you put it in the line, they're gonna perform in a way, if you put the same 10 computers and you put it in the matrix, they're gonna be communicating better, okay? The internet has a scale-free structure, okay? It has very similar to the brain, actually. Anyway, any questions? So the exercise is about a little bit of research, okay? Please depict at least 3 examples of each dimensional configuration. 1D, 2D, and so on. with real organizational configurations. So make some research and try to find out what is the organizational structure of real organizations and give me examples for that, okay? So this is just basically about creating, let's say, a matrix with 1D, 2D, 3D, and 4D, and then say a scale free, okay? So small world, scale free. And then say example 1, example 2, example 3. 4D, scale free, small world, and so on. Okay? Does it make sense? This was one of the questions last year in the exam. Any questions? So we talk about lean management, we talk about socio-technical systems, socio-technical management systems, socio-technical social, one level, technical the other level. We want to achieve goals while increasing trust, that's why it's a management system. We want to reduce process variability, which means reducing standard deviation of processes. We do that with principal component analysis for many dimensions. And another issue that we talked about was networks the other day. So we have different organizational settings here. And I want you to investigate a little bit about this regarding the different organizational structures that we deal with. Okay? Any questions, please? Okay, well then